This is PreCalculus 12, Chapter 7.3. We're going to be looking at reciprocal and quotient identities. We've done this already in Chapter 6. So let's recall the identities. Cosecant theta is 1 over sine theta, and sine theta is not allowed to be 0. Secant theta is 1 over cos theta, and cos theta is not allowed to be 0. Cotangent theta is 1 over tan theta, and here we have sine theta is not allowed to be 0. And cosine as well is not allowed to be 0. And we also have tan theta is equal to sine theta over cos theta, and cos theta is not allowed to be 0. If we have this case where cotangent is equal to cos theta over sine theta, it's just sine theta is not allowed to be 0. So this identity is less restrictive. Now, if we manipulate this identity, we can move sine over to the other side, and we have cosecant theta times sine theta equals 1. Similarly, with this identity, we have secant theta times cos theta equals 1, and with this identity, cotangent theta times tan theta equals 1. Here's some more terminology. Verify. This means we are substituting one or two values to check if the identity works. And this does not mean you can use it for all values. Just because one or two values works, there may be values that do not work. And when you have the case where you're substituting values, one or two values works and the other values don't work, this is called a solution. Proof. This is using algebra to show that the identity works for all values. And for proofs, proper proofs, you are only allowed to use algebra on one side of the identity. And you must show all steps. So you're allowed to work on the left-hand side or the right-hand side, but not both. So let's look at an example. And proofs are very formal, and that's why you must show all steps. You can't skip anything. Okay, you can say left-hand side equals or right-hand side equals. A good tip is to use the side that has more expressions. So we start off left-hand side equals, and we just write it out. Secant theta, sine theta, minus cos theta, minus tan theta. So for this section, when you're stuck, just convert all the trig functions to sine and cosine and see what cancels out. So we have sine theta minus cos theta. That's this part. Now the part that we're changing is secant theta, and we're going to do 1 over cos theta. And we're going to convert this to, this is going to be sine theta over cos theta. Now we have a common denominator. We can just combine the numerator. So we have sine theta, and I'm going to move this over to this side, sine theta, just to make it obvious, minus cos theta. So the cos theta is going to the end, and we're not changing anything here, so I'm going to put it in red. Now we can cancel. I'm canceling because one is positive, one is negative. There's no multiplies in between them. Now we have negative cos theta over cos theta. This is negative 1, and this equals the right-hand side. And if you follow traditional mathematics, we put QED at the end of a proof. And this means quod error demonstratum. And that's Latin. And I'm not going to write it out for you. You can look it up yourself. Or you could say W5. And that stands for which was what we wanted. And I'll write that out. Which was what we wanted. Okay, this is not traditional. This is newer math using W5. And we use it because it's in English. Okay, let's look at another problem. Again, we'll work with the more complicated side. Just write it out. Tan theta cosecant squared theta over secant squared theta. So we'll write the reciprocals of these ones. We'll use the identity for this one. We're going to do everything in one step. Sine theta over cos theta. This is 1 over sine squared theta. Now we're going to divide by 1 over cos squared theta. This part remains the same, so we'll just put that in red. And we're dividing by a fraction, so we're going to multiply by the reciprocal. So this is cos squared theta over 1, but we don't write the 1, so cos squared theta. Now we can go ahead and cancel. We're going to cancel one of the sine thetas, so we're going to cancel 1 from the exponent. We're going to cancel one of the cos thetas, and we're going to cancel from the exponent. This leaves us with cos theta over sine theta, and this equals cotangent theta. That's the identity for cotangent, and that equals the right-hand side, and QED. Okay, either memorize or just keep checking your identities to see what will simplify the expression or make it look like the other side. So we're going to do some more just so that you get used to this. But if you're ready to start proving, go ahead and try. You don't get good without practice. Okay, left-hand side. Again, it's the more complicated side. 1 minus, we're going to break this down into cosine theta over sine theta. And we're going to divide by 1 minus sine theta over cos theta. Don't have much of a choice. We need to have a common denominator. So this is going to change now. This stays the same. And it's sine theta over sine theta. And this one needs to be multiplied by cos theta over cos theta. And this stays the same. Looks like we're doing a lot of work, but a lot of it's just copying what we have from the previous line. Now we have the common denominators. We can combine the numerators. Sine theta minus cos theta all over sine theta. Since this is a simple step, we're going to reciprocate this and do this subtraction. So it's going to be cos theta over this. Cos theta over cos theta minus sine theta. Okay, now we're going to cancel this out. We pull a negative 1 out of here, and we can cancel this out. Okay, we're changing the sign of this, changing the sign of this, so it matches this factor, and then we have to put a negative 1 out front. So we have negative cos theta over sine theta, and this is our cotangent identity, minus cotangent theta, and that equals the right-hand side, and QED. Is this necessary? This is not necessary, but you're honoring mathematicians in the past, and the work that they've done. So in mathematics, what we do is we prove something, and once we've proved it, then people are free to use that rather than going through all these steps again. So what do? Choose to work with the more complex side. This is in general, it's not always the case. Convert all the trig functions to sine and cosine. Again, this is a strategy if you're stuck. We want to simplify to a single fraction, and we want to make the conversion look like the simpler side. Anytime we see a 1, we can change it to whatever we like, but normally it's to have a common denominator. Okay, the difference between an identity equation is that an identity cannot be solved. It will simplify and reduce to a truth. That means 1 equals 1 or 1 equals 0. So this means it's a true identity. This is a false identity. Okay, let's go over some rules for simplifying to no fractions. So we're going to go over some algebra rules. We can only cancel out factors if they are in the numerator and the denominator of the same term. And we're going to practice these rules. We can only cancel out terms if there are no multiplies or divides between them. We can never cancel out factors that are in parameters. Okay, so we have 3 sine x divided by sine 3x, and we can't cancel these out. And we can't cancel it out because of number 3. We can never cancel out factors that are in parameters with numbers that are outside parameters. Okay, let's look at the next one. Sine theta plus cos theta over tan theta minus cos theta. We see two terms that are alike, a positive cos and negative cos. However, we cannot do this by number 2. We can only cancel out factors if there are no multiplies or divides between them. This is being divided by tangent. This is being divided by 1. They don't have a common denominator, therefore we can't cancel them out. Sine x over cos x plus cos x. Canceling here. They look the same. One's in the numerator, one's in the denominator. And we can only cancel out factors if they are in the numerator and denominator of the same term. Okay, so we can't by number 1. Okay, simplify to no fractions means that we have no denominators. So we have to use the reciprocal identities if there's something in the denominator at the end. So we're going to split this up. This is sine theta over cotangent theta, and this is cosine theta over cotangent theta, plus cosine theta over cotangent theta. Okay, and this property that we're using is the distributive property. We can split the fraction. We have sine theta cotangent theta minus cosine theta over cotangent theta plus cosine theta over cotangent theta. Never write cos over cotangent. These are functions. They always require a parameter. If you leave it blank, you're going to lose marks. So we have like terms. They're both cosine theta over cotangent theta. One's negative, one's positive. And now we write sine theta. We write this reciprocal of cotangent theta in the numerator, and that's just tangent theta. So cancel out opposite terms. Plus and minus. And use reciprocal. 1 over cotangent theta equals tan theta. Normally, when you simplify, you can leave out this step because it's the same as this step. We're just showing the canceling. I don't have room to write out the explanations if I leave out this line. Next one. This is very complicated. So we're going to substitute y equals tan x. So we have y squared minus 3y minus 4. That's a lot easier to look at. Sine x tan x plus sine x. Now we can factor this, y minus 4, y plus 1. And we can factor the denominator as well. Pull the sine x out, sine x, and then we're left with tan x plus 1. Factor numerator and denominator. Now we need to substitute back. We have tan x minus 4, tan x plus 1 over sine x, tan x plus 1. I'm going to substitute back, and we're going to cancel. So now we have tan x minus 4 over sine x. And we want to split this up. Tan x over sine x minus 4 over sine x. And we're splitting the fraction. And again, we're using the distributive property. Okay, we want to use the identity for this one. So this is sine x divided by cos x. And we're going to use the reciprocal identity for sine, which is cosecant x. And we can cancel this out. So now we have 1 over cos x minus 4 cosecant x. And the identity for cos is secant x minus 4 cosecant x. And that's as simplified as it gets. So if you need to see how to use your calculator to do this part, please watch the extra segment. Otherwise, that completes this lesson.